I love doing cryptic crosswords. I love doing things like Sudokus and stuff. And doing maths research is like that, but souped up. I'm Aidan Sims. I'm a Professor of Maths at the University of Wollongong, soon to move to the University of New South Wales.
So 1 minus e to the 2 pi.
I'm a mathematician.
So now I guess
I research mathematics and I teach mathematics.
Even negative.
And I love both of those bits of the job. I guess the research that I do, I would call quantum mathematics. What we're trying to understand is mathematics that first came up when scientists were starting to see that things behaved very, very strangely at the very small scale of quantum physics. We need mechanisms, we need ways to picture it, we need ways to manipulate it to help us design, hopefully, quantum devices, quantum computers. But it's a long research pipeline, and what we aim to do is listen to the physicists, listen to the applied mathematicians, find out what it is that they need to know. But we also, I guess, are always conscious that there's a value in doing mathematics because it looks interesting and we're curious about it, because there's such a history of that leading to completely unexpected technological advances. That they couldn't have happened if we didn't have the mathematics, but no one knew that that was the mathematics we were going to need in advance. It just came out of knowing that mathematical theory. The stuff that I started on when I was a PhD student, this was a new visual model for these quantum mathematical systems. And I guess it was something like a 12, 13-year journey from when I started to a paper that I wrote with a couple of collaborators from Denmark and from the States, where we answered a really long-standing question about the structure of these operator algebras using these higher rank graphs. That was a big one. And more recently, there are two sorts of algebras that we deal with, C-star algebras and abstract algebras. And we were seeing that in certain classes of them, there were incredible similarities between what was true about them, but the way that you proved it was completely different. We couldn't see the connection between them. And I had this idea that something that we had in our toolkit called groupoids might be the way to do it. And it was a bit of a long haul, but over about probably a 5-year period, that's what we did. And sure enough, in the end, you can use the groupoid as something that underpins both, and it translates the theorems back and forth. So that was a real proud moment. The people that I see elected to the Australian Academy of Science really are the leaders, like the top people in Australia, and I sort of find it hard to feel that my name belongs in that list of people, but it obviously makes me immensely proud. There's no such thing as just being good at maths or bad at maths. You practice and you get better at it and you struggle with it, and every so often you make a breakthrough, and for just a moment you feel, wow, maybe I'm actually okay at this.